So I'm Jana Osborne. I'm a research software engineer with Princeton and Iris Hub. I work in a team with Jim and other people developing analysis tools for large-scale data processing. And I'm also a member of CMS. And when I'm talking about large-scale data, I also think about large-scale software, which we have at CMS, because CMS software stack is about 5.5 million lines of code, and 60% of it is C++ and 30% is Python. So we actually, to run these things, to run the CMSSW, we need about 650 tools to build and run it. So that's the perspective from which I'm thinking. So we have this sort of like dual language problem, because physicists obviously they want to run their analysis interactively in Python, and they want to run them fast. And C++ is one of the languages which is quite good and suitable for that. So how do we allow them? How do we help them to do it in a sort of easier and efficient way? And in the awkward array project, we have this awkward array C++ dialect, and also some other possibilities to write imperative code, which is faster than just writing for loops in Python. And I have a few notebooks I will go through to show how we can do this. We can use connection to RDataFrame, which is root framework for data processing, and we can use standalone CPPYY. This is all for C++. We can also pass awkward arrays to number and to and from, and do write functions in Python, which can be JIT compiled. And also the same for using GPUs for number. We also have a library, header-only library, and Manasvi, who is connected, she wrote it, to populate awkward arrays from C++ directly, and then just pass them to Python, and so it doesn't need any dependencies in a sense. So we're all familiar with this two-language problem when we have sort of like a code, and we run it, we load the data, we observe, and the physicist wants to just based on the observations, do some modifications and go from the code directly without reloading the data without running. And Python is really perfect for that. For C++, when we write the code, we have to build it, we have to run it, we have to load the data, then we observe and we say, oh yeah, now we need to apply some modifications, and we have to run the full all loop again. So when we're talking about these conversions, we do not compile in a sense. We do not we allow the user stay in the Python environment and JIT compile C++, like for example for RDataFrame. So we provide the to and from functions, and I'll just go to the. Maybe I should just, yeah. So here's the, unfortunately, I had to provide the evaluated notebooks. I didn't manage to create the environments because some of the environments are conflicting. Like, for example, if you have root and you want to have a separate CPPYY, they will conflict. But if you have a root installed locally, you can download the notebook and rerun it. So for conversion to RDataFrame, we need to have root, we need to have awkward array, and for example, the jagged array, like it's shown in this cell, they have to be equal lengths. And then the to RDataFrame function will return the data frame. So this function actually presents does it all on demand and presents awkward array as a view to our data frame source. And there is a small overhead for compiling the C++ code, which actually uses the layout builder to generate this. And you can see that if we check the data frame, our data frame, whether the event loop was run, we see that actually it wasn't. You can see the columns created from the awkward array. They have this is sort of very interesting type, but in fact we don't care about the type, because this is C++ where we can say we just use auto and say we just iterate. We don't care what type is, but we just can iterate over the awkward arrays. And the same, you can check what are the columns X, Y, and Z, and going back from RDataFrame to awkward array is also similar. That you get you ask for the columns by name, and then you receive your awkward array, and you can check that the type of the array is actually an awkward array of variable things. It's also possible to use it in multi-threaded environment. So in this case, you can have your data in Python as awkward arrays, put them in RDataFrame, execute what you need, and get them back or get the results back. And also use all the commands available from RDataFrame directly. Here's an analysis example where we can use the NanoAD data from CMS and say we want to get all the, just load this root file into the data frame and take the data as awkward arrays. So we'll get about 60 million events, and it's all jagged arrays where we can see that we have muon charge, muon eta, mass, phi, pt, a number of muons. And then what we can do with it, we can just add additional C++ code to execute, because at this point, nothing was run. The RDataFrame was not executing the loop. So you can see that we're scheduling we'll define a new column, and this string is part of C++ code. We're actually accessing the events, and in awkward array is actually done the following way by the name. So this is for the awkward to and from RDataFrame. What about standalone CPPYY? The standalone CPPYY, we're using the master branch because the latest features which we rely on are not available yet from the release. And in this case, awkward arrays provide additional type of define its C++ type as a string, which CPPYY is using to connect the C++ type of the array with the Python type. So in this case, here's just I'm telling that don't believe this version because I'm taking it from master updated to 3.0.1. And for the awkward array, we can just say, okay, we just write some C++ code, which can be templated, which is very convenient because we don't need to know the type C++. We just say, okay, we'll just take whatever type you give us as auto, and we iterate over the array itself. We iterate over the list, and we iterate over the records and take the Y from each of the records, and we do something about it. Say we just do the sum. For CPPYY, we need to define this function. The downside that when you define a function for CPPYY, it has to have a unique name. So if you define the function once and you want to change it, you have to rename it. Otherwise, one of the things, if you want to reuse the same name of the function, you will have to restart the code, because this all goes in a global map. And then we can just say, okay, we just invoke this function, and we pass the type, the C++ type of the array. We don't know what the type is, and we don't care. But the awkward array actually generates this type on the fly, and this is the attribute of this particular array. And we can check that actually the function calculates the correct sum, because we also have some functions in awkward array who do similar things. And for comparison, I just use the sum of array field y. Timing-wise, the execution of this function is faster than awkward array function. And for comparison, the Python loop over the array would be, you can see that it's quite significantly slower. So this is another way of connecting Python and C++, and the way of writing the imperative code, fast imperative code, actually. I'm sure that everybody knows about number, and awkward arrays are, it's possible to use it with number directly, because we generate the array view and declare it for number to actually understand. And all you need to do is just to add the decorator, say, I want to JIT this awkward array, and then you access the array as usual. So number will recognize, it will register, it will do all the magic behind the scenes. When we're talking about number on GPU for CUDA target, there is a little bit of more work needs to be done on the user side, because it hasn't been implemented the need of registering extension. Because similar, the decorator for number CUDA for JITting would have to take the extension from awkward array that declares the parameters of the array view generated for this particular Python array. So that those parameters have to be lowered, and then it's understood by number. So that's the only thing for now you would need to add. Eventually, we will just work with number to, there is an issue asking them to implement the registration automatically. So eventually this will go away. But then when you define the function and pass the awkward array, you can do whatever you want to do, access the array. For example, here it's just I'm calculating the length. The only thing, you cannot take awkward array out of GPUs. You have to declare the output and pass it to the function. And here's, for example, how we can do this on the GPU. So we define a big array, and then invoke it with the function path length. Again, we define the result outside of the function and declare it as occupy empty array of the length of the array, because we know what we're getting back. Time-wise, if we check we run on GPU, or we do similar things with awkward array. So you can see that 180 microseconds or 7.5 milliseconds, but the result is the same. So we can just compare the result. So for the generated array, we get exactly the same result. So this is another way of speeding up the imperative code on awkward arrays. So the next thing is the layout the layout builder, which is a header-only library, and it's quite convenient if you have a lot of C++ code and you want to jump to Python, and you want to create your awkward arrays and continue processing, analyzing the data in Python ecosystem. So the header-only layout builder, you just include the header file, and then you define the particular builder, because in this case you actually need to know what kind of array you're building. And here's an example for the record builder, when we define record field, and one of the records is going to be NumPy-like array, and another one's going to be list of set array of NumPy array, and then you just say I want to have to fill the field 1 or field 2, and append the data, for example, in a for loop, or by copying, by extending appending multiple that data to the field. And because it's C++, this is fast. And then to retrieve it, we can just ask the builder how big are the buffers we need to actually retrieve the data from you, and it will give you the map of buffers with the names, and after that we can just fill it in. It's also possible to use PyBind 11, for example, buffer protocol, and I would encourage you to look at the awkward documentation for more details. It's very well documented. And the last, this is thanks to Jim. We had an exciting new development, awkward arrays in Julia, and you would say, why Julia? And I think it's really a major milestone in programming languages evolution. So I think it's probably the language of the future. Unfortunately, we have a lot of legacy software, and this is one of the stepping stones where we can actually try Julia without completely rewriting everything. We can just go to from Python to Julia, from Julia to Python, and using awkward arrays is similar like using other packages in Julia. If you're familiar with Julia, you can just say, I want to use all my REPL or revise or debugger, which are quite nice, all these packages. Or you can just say, I use using awkward array, or even using from awkward array specific arrays like list of set array, primitive array, and then define the arrays themselves, push the data, and see that you actually can have all this functionality in the future. entirely because this is still under development. When we can use, for example, PyCall, and we can import NumPy and execute Python function. NumPy, for example, to calculate something. We would be able to do the same for awkward functions and use similar things just to try. And for more information, please check this repository. So to summarize, we have this dialects in awkward arrays, and I encourage you to try it and communicate to us what exactly you like, what works for you, what doesn't work for you, and maybe we can improve. Thank you very much.
And thank you, Jana, for this really nice and comprehensive talk. This is great. All right, so I have one question, but I'm going to first go to check to see if we have any hands raised on Zoom or if anyone has comments in the chat. Let me check. Okay, so it seems like no. So I'll go ahead and ask mine. So this was really interesting. You also were demoing some of the these like upcoming features that are going to be that will need some future release support. In general, for people who watched this talk and thought, oh wow, that's like super cool, what's the best way for people to stay informed in the kind of I guess I'll call it like the awkward ecosystem or the awkward universe about all of these kind of upcoming features and all this nice work?
I think I'll pass it to Angus. I think we have lots of channels to communicate, and probably Angus can answer better than me.
Yes, certainly. So, I mean, the main way that we get feedback and low latency feedback on things is if you come and make issues or discussions on the awkward array repository. The links will be in Jana's slides somewhere. We have other channels that we communicate on, like on Gitter. I think Jim also is aware of Mattermost, and on Stack Overflow, but we're trying to move away from Stack Overflow in the long run. So I think the GitHub repository is probably the best place to keep tabs on things. When we make releases, we will release the changed features in our releases. So keep an eye on the releases if you just want to subscribe to the new features.
Okay, great. And then maybe this is given that Jana mentioned that Jim had been doing the Awkward and Julia development, maybe this is a question for Jim, but for those of us who are not really well versed in the Julia universe yet, if we have I know that this is still like kind of developmental, but if you have like a Julia runtime and you have awkward installed, can you basically, or not awkward installed, but if you have a Julia runtime and you just try and like install and use Julia, or install and use awkward from Julia, will this work out of the box today, the examples that were shown, or does that require some additional work in the Julia wrapper package?
Yeah, all of the examples shown do work.
Awesome.
So the way that Julia packages are distributed is on GitHub, or some Git, I suppose. I don't think that awkwardarray.jl has been put in the Julia registry yet, but that's something we want to do. And it's also not necessary to be able to install it. What's missing from that is the zero copy converter between the Python awkward arrays and the Julia awkward arrays, so that you can use the two languages together. And Jana showed some examples with PyCall, although those were not using awkward array. Those examples. So that's the work to be done. But that's kind of how we see this, that Jana showed here a lot of different compiled backends for awkward array, where you can write code that operates on awkward arrays where the data structure is in Python. And in one way, you could see Julia as being another compiled backend. And that's sort of the main, or at least first, way that we want to present this.
Okay, great. Thanks very much for that answer. Okay, so let me check again before to see if we have any hands raised or any questions. Looks like no. Oh, okay. We actually have two that came up. So Zana, do you want to unmute and ask your question?
Somebody hear me?
Yeah.
Excuse me, but it's a question about the previous lecture, if it not very disturbing.
Okay. Yeah, maybe we can take that to the Slack channel then. And then we also had a question about Mojo and I guess that, like, the views on Mojo and awkward.
So then I suppose if it's for either Jana or me to answer, I could go.
Yeah, Jim, go ahead.
Mojo is a Python replacement. The idea is that it has mostly Python syntax, but it extends beyond it, and it is a replacement for the CPython interpreter. So when you use Mojo, you can't use the rest of the Python ecosystem packages. At least that's as it's defined now. I don't know if they plan to make it more compatible with the Python ecosystem, the way that PyPy has. It's become possible to use Python ecosystem packages in PyPy. So okay, so ask my opinion. My opinion about Mojo is I don't see what the value added is, because you have to leave the Python environment. You don't get access to all of those Python packages, and you do that for the sake of doing some additional JIT compilation. But there are a lot of JIT ways to do JIT compilation from Python. There's Numba, there's Julia through PyJulia, there's C++ through CPURY and RDataFrame. So my opinion is, why try to make a clean break from Python when we can do when Python is such excellent glue language?
Okay, so I think that is I don't see any other questions in the Monday session 2 chat. So I think that brings us to the end.